Okay, we're back. I went ahead and painted the box, drilled the holes, painted the box, put it in the laser, put the artwork on there. I think it came out good. Put my little Lynx logo on it, on and off labels for the switch. I think it turned out quite good. So now I'm interested to see how I can get these LEDs in and figure out how to get them in, get them soldered with this mounted in. I went ahead and cut the positive wire on the battery clip, put the switch in so that it's ready to go. Challenge, I think, for the LEDs, let's see here now. The negative input one is going to be the red one. And so maybe what I can do to help myself out a little here is just put a little bend on the very end of these so that it can't fall out. Because I don't know how long it's going to stick through when it's done. And then we have the other two. Hopefully I got it right here. I got these two in, bent a little bit so they can't fall out of the holes. And then we'll kind of hang it down, see if I can get it in the holes. Maybe I can make this work. So, oops, that one didn't stay in very well. Let's bend him a little more, give him a little more. Don't want to come out of there kind of thing. I'm sure these are bent enough. Okay, now let's see if they'll stay in there. Okay, so I got these lined up on the holes and then get these LEDs to go in their holes. That wasn't too hard. Okay, so we got them mounted in there. LEDs, get them in there. And now, piece of paper in here. I don't want this thing sitting down on the LEDs and pushing them back through. So what I'm going to do is I'm going to kind of prop it up a little here. Get my soldering iron and get that soldered in. And then we can clip off those leads. Okay. Now, we need to get our switch put in, which is just a matter of plugging this guy in. And let's see, she's in the which position? She's in the on position. So okay, there's our switch. And now I need to come up with a 9-volt battery, a little bit of foam. So let me jump and try to find that real quick. I'll be right back. Okay, I went and found a new 9-volt battery. Got me a little foam, got me a little square here, and we should be able to plug this guy in. Squish him down in there good like that. And this lid will go on. Oh yeah. And did we get some LEDs? Oh yeah, look at that. I got power. Stage 1's okay. I don't have a negative input. I'll have to test that at some point by putting a very low negative input for just a very short time. That's what he recommends, like, very little. just to make sure it comes on and shows you. This is to warn you that you're putting a negative input in, which is a no-no, and it won't put up with that very long. You can damage it. So he's got a nice little warning light there for us to let us know that we need to stop. We're messing up. So kind of looks like it's working. We'll know more when we start the testing. Let me go ahead and get the screws in here. We'll close her up. And we should have a nice little extremely low noise, ultra low noise amplifier that will allow us to amplify those very low signals to see how much noise are in them. And it's well below my instrument's capabilities. Very interested to see how this thing performs. Not sure, how. I know I can't test it as well as he can, the guy that creates them or makes them, because he's got some nice Rode and Schwartz stuff to test them with. And he sent me, as you saw, we know how this thing should perform because it's already been tested. Now I get to test it with my stuff and see what I think. So I'm going to have to get rigged up for that. I'm not going to do it right at the moment. Got a lot of things going on. I'll be back and we'll pick up and put this thing to the paces and see what it does. So I think it's looking really good in my opinion. I hope you guys like it. And can't wait to see how it does. So don't go anywhere. Okay, we're on the bench. Let's check these things out and compare the two LNAs. Of course, I've got the one we just finished, and I've got the Dexter 1010 right here. If you look at the oscilloscope, channel 2 here is the Dexter, and that's what the noise coming out of the Dexter looks like. Okay, at my lowest scale on the Rigel. Now, one thing I got to point out is this scale here, on this channel 1, I should say, channel 1 is capped off and shorted. So as you can see, the Rigel is not a super quiet oscilloscope. It's never been known to be a super low noise oscilloscope. So the noise on it is really hard to get under around 100, 120 microvolts. So with this, it's way above that, to the point that we can easily see the noise. With this one, what we're going to find is when I uncap it and put this on, you're not really going to see much change. And the reason you're not going to see much change to channel 1 is because this is putting out way lower noise than that oscilloscope's generating. So I really don't have a scope that's going to pick up the low levels of this thing. So it's not going to be possible for me to measure it down and get the same spec the gentleman who designed it is. He's using a much better oscilloscope with a much lower noise, that Rode and Schwartz, much lower noise floor. Let's take a look at what this one looks like. And I think what you're going to find is when I uncap it, you might see a slight increase there. I did. But when I put this on, I think you're going to notice it really doesn't make a big difference to the noise. And this will sit here and stabilize out even better over time as the capacitor kind of forms and settles out. There's a period of time when you first hook them up and they're flowing current that they take to calm down when you use this type of setup. But as you can see, it's quite a dramatic difference in the noise between the Dexter and this unit. And my feeling, just kind of taking a look here, I think the new LNA would meet its specs. If I had the oscilloscope to do it with, I think I could get the same specs that he's getting. It's quite low. It's a very quiet LNA. You also have to remember that some of the noise being generated in these devices will be before the amplifier, and therefore for at least one of the stages. And so therefore you're amplifying that too. So that makes it very difficult. But in the case of the Dexter, you're doing 1,000 amplification, but you have to remember it's 10,000 with this one. Now, I know I said 1,000 in the video by accident, but I put on the screen, I put it, when I saw I did that while editing, I put a title to remind everybody that I meant 10,000. This thing is, the main output is 10,000. There's a intermediate stage that you can pick up on 250. And so we could switch over that 250. We'll aggravate it a little bit doing it. But let me swap this over. Let's put it on the 250. And the 250, you can't tell the difference, at least here. So that's how quiet it is. Because while you might be generating the same noise before that stage, you're only amplifying at 250, not 10,000. So let me pull it over. So what I'm trying to get across, so that I can be clear, is that my scope has a limit to how low it can measure down noise because of its own noise. So we just can't see it on this amp because it's less than the scope generates on its own. On the other hand, the Dexter puts out a lot more than my scope, and we can readily see it. That's the point I'm trying to make if I'm not being clear. So the next thing I want to do is, we looked at it on the scope, but I have this old Hewlett-Packard 34A RMS voltmeter, which is the perfect device for measuring noise on the signals. And so I've got it set up here. I've got it on the lowest range, which is 1 millivolt, which means full scale 1.0 over here is a millivolt. And I've got it shorted, and you can see that it's reading just over 0. It's not quite perfectly 0, but it's pretty good. Bear in mind, the range at this level way down here is not that accurate. They tell you to make sure to try to keep your measurements by ranging up into the scale, at least 2 to 4, somewhere up in here. You can see where the decimals are. They really prefer you to measure somewhere inside that decimal scale for accuracy of this meter. And fortunately, what we're going to be measuring with this one is going to be below that at the lowest range. There's just no way for me to do it. So we won't have a perfectly accurate, but it'll give us a great representative number of the noise comparative to the Dexter. So let's do this. Let's uncap it. It's going to go crazy because it's going to start seeing stuff. And if you ever wondered, my old meter I rebuilt here, if you ever wonder how sensitive these things are, let me just give you a little sample. Okay, it's sitting here and it's reading noise just floating around in the air, but all I have to do is move my hand near it, and I can make that needle go crazy. I'm not touching, as you can see, I'm not touching the connector. I'm just moving around it, and just because I'm a big antenna, I can cause that thing to that's how sensitive of a device we're talking about here. So I'm going to go ahead and hook up the Dexter, and it's going to go crazy as it does its thing. It takes a moment with these meters to settle the way they work, to settle around. They'll bounce around a little bit, and finally they'll calm down. There she is. All right, so what are we reading here? Well, we're reading around 0.9 millivolts. 0.9 millivolts, thousandths of a volt. Okay, that's the noise level it's seeing on the signal. Okay, that's our RMS. So the question would be, how does that compare at 1,000 amplification compared to this new device at 10,000? You'd expect a lot more out of this if they were comparable. So let's hook our new amplifier up and let's see what we see. Again, it's going to go crazy for a little bit. It's going to go negative. It's going to slam the needle one way. It's going to come back. It's finally going to calm down some. And when it calms down, where's it going to be? It's going to be way down there. It's going to be out of the range of super accuracy. And the thing to remember is, because we've got a big capacitor in here and you started flowing a different amount of current, it's going to take time for that to settle out. So one of the things about these type is you have to give them time to settle. And this thing will settle, usually come up lower and lower. You can see it keeps going a little bit lower. It bounces up for a little bit, comes back lower. And it'll settle down some after, sometimes you need to wait 15 minutes. Some of these, it's an hour, but you need to give them time to settle out. But you can see already how much lower this thing's going to be compared. It's going to be dramatic. But you can see it's 40, 50 microvolts. And the target is around 10 microvolts is what he's saying. So 10, 11 microvolts is what he's claiming. I very well believe this thing can do it. So anyway, I can say for sure this is working, and it's absolutely immensely quieter. So the next question we would have is it amplifying? Is it doing what it's supposed to on amplifying? So give me a minute to set up, and we'll try and see what we find on amplification, okay? All right, so I got it set up. Let me show you what I got. Okay, my signal generator over here is putting out 500 millivolts peak to peak. Now, I've got my attenuator in line, and I've got 60 dB of pad put in there. So that's a voltage-wise, that's 1,000 reduction of voltage. So we've got 500 millivolt being reduced by 1,000. So we're actually only getting 0.5 millivolts, 500 microvolts input into the amplifier. Now on the 10,000 output, I'm seeing in the neighborhood of 6 volts, 6.08 volts peak to peak. Okay. If you do the math on that, that's a little over 10,000 actually, which is interesting. But you know, every one of these belts, the gain is a little bit different. In fact, I've got the numbers of what this one actually is from his measurements. And believe me, I trust his measurements more accurately than mine. On the 2-volt scale here, you can see here's my signal. I'm getting a peak to peak of 6 volts out of 500 microvolts, half a millivolt. So if you take that, that's half a millivolt into this amp. So 500 millivolts, 1,000 times reduction in voltage, half a millivolt, 500 microvolts, into the amp yields me 6 volts. We're definitely getting 10,000 multiplication out of it. Let's go over and try the 250 now. We're going to come way down on amplification. This signal, I might have to make some changes because the signal is going to be so much smaller coming out. There's 250 times. Let's go down a range and see if we can see that. There it is. The signal's there. Oops, went too far. Okay, there's 50 millivolt range, and it says the peak to peak is 146 millivolts. So I would have expected, what, 125 millivolts if I'm doing it in my head real quick correctly and not doing my typical messing up, because I'm looking at 0.5 millivolts going in. So at 1 millivolt, I would have expected 250 millivolts, but I'm looking for half of that. Well, half of 250, right, is 125. So we would have looked for about 125. We're a little bit high on here, which matches with the 10,000 gain. Now, maybe that's inaccuracy in my attenuator, but I think my attenuator is pretty accurate. We're looking at really small things here, so it can matter. So anyway, it definitely looks like it's doing what it's supposed to do. We can, let's turn it off and verify that we are getting the signal from the amplifier. So I'm really happy. It's working really, really well. I hope you've enjoyed this little excursion in trying to get into very precision voltage low noise amplifiers. You're going to see me use this in the upcoming videos. We're going to build a test power supply circuit for the voltage calibrator, look at what kind of noise it's generating, and we're going to compare that to like a typical linear, 7812, or typically what you'd build in a circuit if you weren't worried about noise so much. And we're going to see how big a difference there is. Is it just smoke and mirrors, or does it really matter? Is it really that much different? Look forward to that video. So hey, thanks for hanging out with me. Hope you enjoyed it. Hope you learned something. But most of all, I hope you'll smash that like button, subscribe if you haven't, and catch me in my next video.